Hello everyone, welcome back to my YouTube channel. Today we'll be discussing another fundamental topic of maths, that is real numbers. We'll have a discussion about the basic concepts of real numbers, like its types, its applications and its properties. Let us have an introduction to the topic. Real numbers are numbers that can be formed on a number line. They include rational and irrational numbers. Rational numbers are those numbers which can be expressed as a fraction, while irrational numbers are those numbers which cannot be expressed as a fraction. The set of real numbers is represented by symbol R. Let us see the classification of real numbers to understand what are rational numbers and irrational numbers. Let us discuss the classification of real numbers. As you can see here, let us discuss first natural numbers. Natural numbers are those numbers which contain all counting numbers which start from 1. For example, 1, 2, 3, 4, 5 and so on till infinity. So this contains all positive numbers. Then comes whole number. Whole number contains natural numbers and 0. So 0 is included, it is a collection of 0 and natural numbers. Then comes the integers. Integers are those numbers which includes 0 also, positive numbers that are natural numbers as well as negative numbers. So here -2, -1, 0, 1, 2, -3, -4, +3, +4. All the negative numbers, positive numbers as well as 0 will be included in integer. Then comes the rational numbers. In rational numbers, the decimal numbers or fraction numbers are also included, like numbers that can be written in the form of p upon q, where denominator is not equal to 0. Examples 1 by 2, 5 by 4, 12 by 6. So these are the examples of rational numbers. Rational numbers can also include negative numbers like -5 by 2, -6.92. So basically rational numbers, in rational numbers we have category as integer, whole numbers and natural numbers. So we can say that integer, whole number and natural numbers are a subset of rational numbers. So rational number is one set, and in that set we have included whole numbers, natural numbers and integers. Another set is the irrational numbers. This is different from rational numbers. Irrational numbers are such numbers which are not rational and which cannot be written in the form of p upon q. Like you can see our example, pi, root 2, root, root 2 and pi. So value of pi is endless. If you see the value of pi, it is 3.142 and the digit after the decimal are endless. It goes continuously. So these are included in different classification, that is irrational numbers. Similarly, the value of root 2 is also endless and there are no repeating numbers after the decimal. So these are the classification of real numbers, and both the numbers, rational as well as irrational numbers, together form real numbers. So we can say that rational numbers and irrational numbers are a subset of real numbers. Let's do one task. Now we have to classify the numbers into rational numbers and irrational numbers. First number is 3 by 4. Just remember the definition of rational numbers. The numbers which are expressed in the form of fraction, they are rational numbers. And as you can see here, the denominator is also not equal to 0. I can say that 3 by 4 is a rational number. Similarly, the next number 1 by 2, it's again a rational number as it is expressed in the form of fraction. Next is 5. Now 5 is a positive number and we know that natural numbers are positive numbers and is a countable number and it comes under rational numbers. Here also we can express in the form of fraction by writing 5 upon 1. Generally when the denominator is 1, we do not prefer to write 1 in the denominator. So all the three numbers are rational numbers. Next is root 2. Now root 2 is an irrational number because after decimal point the digits are endless and there are no repeating digits after the decimal point. So root 2 comes under irrational numbers. Next is 3.4567, and as you can see that it is endless, it goes on continue, the digits are non-repeating. Again, this is an example of irrational number. 8 by 3. So 8 by 3 is an example of rational number as it is in fraction form. 1.62345 and continue. So this is again example of irrational number as the digits are not repeating. 3.142 and endless digits, again this is example of irrational number. The last one is root 49. Now root 49, we know that we can simplify it as, we can write 49 as a square of 7. Square of 7 is 49 and there is a root here. Now this root and the square both gets cancelled and the number remains is 7. So we can say that 7 is nothing but a rational number. That means root 49 is nothing but a rational number. I hope you understood what is rational numbers and irrational numbers. So here is our number line. So as you can see here on the number line, we have digits. On the left side we have negative numbers, on the right side we have positive numbers, and in the middle we have 0. So the right side, the positive numbers, they are termed as natural numbers, and if you include 0 it is termed as whole numbers, and if you include negative numbers, 0 and positive numbers, it is termed as integers. All these numbers can be plotted in the number line, that's why they are included in rational numbers. In between these digits also there are some decimal numbers, they are included in the rational numbers. So these are the rational numbers on number line. As you can see, 0 and 1, in between there are decimal numbers like 0.1, 0.2, 0.3 and so on. So these numbers are rational numbers. They can be also plotted on a number line. Okay, now we have to plot 3 upon 4 on a number line. So as you can see, 3 upon 4, it is less than 1 and greater than 0. So it is 0 point something. So what we will do, we'll first mark one point as 0 and one point as 1. So 3 by 4 will lie somewhere between 0 and 1. So how we are going to plot it? So after 0, we'll break the lines, or we'll break the number line into 4 parts till 1 equally. We have to break it equally. So after 0, this is my first part, second part, third part, and the fourth part I have already plotted. It's 1. So if you can see, it is 0, 1 by 4, 2 by 4, 3 by 4, and the last one is 4 by 4, which we can write as 1. So this is how you plot 3 by 4. So we have to plot here 3 by 4. This point is our 3 upon 4. Similarly, you can plot different digits on a number line. So this is how rational numbers are plotted on a number line. This was a simple example. So let us have a summary of what we have learned till now. So we classify real numbers into two, rational numbers and irrational numbers. Rational numbers are further categorized into integers and non-integers. Integers means which are positive numbers, 0 and negative numbers. Non-integer numbers are decimal numbers or the number which can be expressed in fractions. So integers can be further classified negative and whole numbers. Whole numbers are further classified into 0 and natural numbers. And natural numbers are nothing but positive numbers. So this is what is summary of real numbers. Now let us discuss about properties of real numbers. Basically there are four main properties of real numbers. First is commutative property, second is associative property, third is distributive property, and fourth one is identity property. We'll discuss them one by one. Let us discuss what is commutative property. Let us consider there are two numbers m and n respectively. The commutative properties say that if I add m plus n and if I add n plus m, I will get the same results. Also, if I multiply m into n or if I multiply n into m, I will get same results. For example, if I add 9 plus 3 or 3 plus 9, the results will be same. 9 plus 3 will be 12, 3 plus 9 will be also 12. Similarly, 2 plus 5 it will be 7, 5 plus 2 will be 7. Means that the order doesn't matters. You take 9 first, then 3 and add them, or you take 3 first and then 9 and add them. The final result will be same. This is what the commutative property. And for multiplication, 5 into 2 will also give you 10, 2 into 5 also give you 10. 7 into 4 will give 28, 4 into 7 will also give you 28. So the order doesn't matter here, the results will be same. This is what commutative property. Let us discuss what is associative property. Consider three numbers m, n and r. So associative property states that m plus bracket n plus r is equal to bracket m plus n plus r. Okay, this is for addition. And for multiplication, multiply m and n first, then multiply with r, or multiply n and r first and multiply with m. Let us understand this with an example. So see here, I am adding 8 plus bracket 3 plus 5. So first I am adding 3 and 5. 5 plus 3 I will get 8. Then I am adding it with 8 again. So I will get 16. In this next case, I am adding 8 and 3 first. Here I add 3 and 5 plus first, and now here I am adding 8 and 3 first. So 8 and 3 will give you 11, and 11 plus 5 will again give you 16. So here also the order doesn't matter. Add any two digit first and add their result with the third digit. The answer is going to be same. Similarly with multiplication, 2 into 3 into 4. Here first I have multiplied 2 into 3, that is 6, and then I have multiplied with 4, it will give 24. And in right hand side, first we have multiplied 3 into 4, so it will give you 12, and 12 2s are 24. In the both the case, your result is 24 only. So this is what the associative property. Let's discuss about distributive property. So in distributive property, let us consider three numbers m, n and r. So as you can see in the general formula, m into n plus r is equal to m into n plus m into r. Now what is this? Now in this case, this m which is outside the bracket, this m is common for n and r. That's why it is distributed to n and r. For example, 4 into 2 plus 3. Now this 4 which is outside the bracket, is first distributed to 2. So 4 into 2 plus 4 is again distributed to 3. 4 into 3. This is what the distributive property. 4 2s I will give you 8. 4 3s I will give you 12. And 12 plus 8 will be 20. Talking about the left hand side, if you add 3 and 2 first, if you don't distribute 4 into 2 and 3, if you just add 3 and 2, so you'll get 5, and again 5 4s are 20. So in both the cases, your answer remains the same, that is 20. This is what distributive property. Other property, the last property, that is identity property for addition and for multiplication. Now see, identity means same, identical, it means same. If I am taking a number, let's say 5, I am adding 0 to it. So my answer will remain 5 only. So the answer remains same when I add 0 to any number. So therefore 0 is known as the additive identity. Similarly, if I multiply 5 with 1, again I am going to get same answer 5. So 1 is known as multiplicative identity. That means if you add 0 to any number, you will get same answer. If you multiply 1 with any number, you are going to get same answer. That is why this property is known as identity property. I hope you are clear with all the properties which we have discussed today. Let us have a discussion about real world applications of real numbers. So there are many real world applications which include in finance, science and engineering. They are used to represent measurements, distance and quantities of all kinds. They are also used in codings and computer science. To today's topic. So real numbers, they are essential part of mathematics and world around us. So real numbers, they include both rational and irrational numbers, and as we discuss the properties and applications of real numbers. So understanding a real numbers is very crucial. So I hope you understood what are real numbers, their classification, application and properties. If you found this video interesting, do like, share and subscribe our channel. Thank you.